Module 9 discusses Concurrence Point 4B, 30% hydraulic review, and Concurrence Point 4C, permit drawings review. This module will cover efforts required for Concurrence Points 4B and 4C for Process 1 and 2 projects. This slide depicts a snapshot of the specific steps associated with building from a Concurrence Point 4A to 4B for both processes. Concurrence Point 4B for Processes 1 and 2 is the review of 30% hydraulic plans. While the steps leading from Concurrence Point 4A to 4B are numbered differently for Processes 1 and 2, the steps are the same for the information required. NCDOT and FHWA will prepare the Final Environmental Impact Statement, or FENSI, which includes the rationale behind the selection of the least environmentally damaging practicable alternative, LEDPA. It is not necessary to complete Concurrence Point 4A prior to the completion of the Final Environmental Impact Statement, or FENSI. NCDOT and FHWA will sign the title page of the Final Environmental Document, FEIS or FENSI, prior to distribution by NCDOT. If FHWA expects to issue a FENSI for a highway project of 4 or more lanes on new location or a new controlled access freeway, copies of the EA shall be made available for public review for a minimum of 30 days before FHWA makes its final decision. The agencies and the public may submit written comments to NCDOT and FHWA concerning the FEIS or FENSI document. In consultation with FHWA, NCDOT will respond directly to the commenting agencies concerning comments received on a FENSI. Comments received on an FEIS will be addressed in the Record of Decision, or ROD, with copies provided to the commenting agency. Normally, FHWA will issue the ROD, which will address any comments received on the FEIS. A notice of availability will then be issued by FHWA. For Process 1, a corridor design public hearing was held after the Draft Environmental Impact Statement, Draft EIS, or the Environmental Assessment, EA, was completed to display the selected alternative and to review any changes that were made within the design during the remainder of the NEPA process. The design public hearing or public information meeting should be held prior to the project being sent to right-of-way. Comments from the public will be reviewed to determine any needed changes. Changes requested from the public and accepted by the project team, if necessary, will be incorporated into the design prior to completion of right-of-way plans. For Process 1 and 2, after selection of the LEDPA, the design engineers will develop the right-of-way plans, following the alignment that was agreed upon at Concurrence Point 4A. Right-of-way plans are prepared using actual field surveys. At the time the hydraulic design for the project is 30% complete, the hydraulics project engineer will hold a Concurrence Point 4B meeting to review the development of the drainage design. All appropriate project team members should attend, with the U.S. Army Corps of Engineers and NC Division of Water Resources attendance mandatory. If the project is within a CAMA county or counties, North Carolina Division of Coastal Management attendance is mandatory. The hydraulics project engineer will provide the package of information to team members so that they receive it 2 weeks in advance of the meeting. Also, before the Concurrence Point 4B meeting is held, the hydraulics project engineer will consult with the NCDOT Natural Environment Section staff to ensure that the environmental surveys, wetlands, threatened and endangered species, streams, and buffer for each project is complete and current. At the 4B meeting, the hydraulics project engineer will present preliminary drainage designs to the team members. The drainage plans will depict the boundaries of the affected environmental areas, wetlands, perennial and intermittent streams, buffers, Coastal Area Management Act areas of environmental concern, etc., existing drainage structures, layout of proposed drainage structures, and stormwater best management devices. Large structures such as bridges and box culverts will also be discussed. It is understood minor vertical changes may be needed due to hydraulic needs. If vertical changes do occur that result in additional environmental impacts, minor horizontal adjustments in alignment may be appropriate. Information required for the Concurrence 4B meeting includes preliminary bridge survey reports, preliminary culvert survey reports, preliminary stormwater design and BMPs, preliminary hazardous spill retention basins, FEMA flood insurance compliance, on-site stream and/or wetland mitigation. Note, candidate sites for on-site mitigation estimates will be finalized in Concurrence Point 4C. This is an example of a roadway interchange with stream and wetland delineation. The challenge here is to determine alternatives for environmental avoidance during and after construction to construct this interchange. Here are some examples of best management practices, BMP, toolboxes to consider during design. This is an example of a grass swale that receives stormwater flow from a system. The grass swale is incorporated in the design to provide pollutant removal from stormwater before it enters a live stream. An example of another BMP toolbox is the level spreader shown on the design drawing that is used to disperse concentrated stormwater flow for pollutant removal and to provide energy dissipation from a stormwater system. This is a photograph of a level spreader similar to the previous design drawing. Note the concrete trough used to carry the flow, with the grass embankment used to spread and treat the stormwater when the concrete trough overflows. Major structures, including reinforced concrete box culverts, are designed with features to simulate natural stream flow. One of those features are concrete sills. Concrete sills are provided to maintain a natural low flow path and to provide a method to hold natural stream material in the culvert to provide a soil substrate instead of a concrete culvert bottom. This is another view of a box culvert detailing a low flow channel through the culvert. Box culverts are typically several feet wide and can have added features to help simulate natural stream flow with baffles. Baffles are placed inside the culvert and are staggered to simulate low flow in meandering through the culvert. The purpose of baffles, sills, and bottomless culverts is to provide a more natural substrate for fish and the riparian ecosystem. A structure that is sometimes used for stream crossings is a bottomless culvert. These are beneficial in that the stream bottom is less disturbed during construction and the natural stream bottom section is preserved. Bottomless culverts can only be used when the stream has shallow rock to support the culvert. Significant scour can occur if they are used in other geologic locations. Culverts can also be designed that provide an aesthetic value to the surrounding area. This is a bottomless culvert, but shaped as an arch. Concurrence Point 4B is the step where preliminary recommendations of construction methods for proposed bridges and culverts will also be discussed. It includes information on preliminary types of bridge superstructure, preliminary location and types of bridge substructure, and preliminary types of construction methods such as top-down construction, temporary work bridges, or temporary rock causeways. To provide adequate information on construction methods, a bridge survey report is provided to the merger team. This report shows the existing bridge, the proposed bridge, and if any channel improvements are proposed. This is an example of the plan and profile drawing of the bridge survey report. This example shows alternate bridge layouts in different colors, which can be discussed at the meeting. The Concurrence 4B meeting is focused on specific impacts to streams and wetlands, such as where the bridge supports are in relation to the stream. One of the most important topics that is often of great interest to the merger team is how the bridge will be built. Heavy equipment is needed to install piles, pour concrete, and set girders. Temporary impacts of this equipment must be explained at the merger meeting so that everyone understands the constructability issues. The merger team may ask if alternative construction methods have been considered. Top-down construction sometimes will provide less impacts, but at higher construction costs. This list shows avoidance and minimization measures that should be considered during the steps leading to the Concurrence Point 4C meeting. The hydraulics engineer will record minutes of the 4B meeting outlining topics discussed and any required follow-up items. These will be provided to team members for review and comment. Final 4B meeting minutes will be included at the 4C meeting with permit drawings. This slide depicts a snapshot of the specific steps associated with building from Concurrence Point 4B to 4C for processes 1 and 2. Concurrence Point 4C and the steps leading to Concurrence Point 4C are the same for processes 1 and 2. Note that scheduling and preparing for the pre-application meeting is the NCDOT Natural Environment Section's responsibility. After the 4B meeting, the hydraulics design engineers will incorporate agencies' comments into their final hydraulic and drainage designs. Then the design engineers will hold the final design field inspection to review the design plans with division construction, roadside environmental, right-of-way, utility personnel. The design engineer will then complete the final hydraulic and drainage designs, develop draft permit drawings, and hold the 4C meeting with the resource agencies. Upon receiving the completed hydraulic design for the project, NCDOT design engineers will incorporate the hydraulic design, locate any remaining service road locations, and establish the proposed right-of-way limits for the project. The right-of-way plans are completed and sent to the right-of-way branch to begin purchase of land required for the project. Steps 30 and 31 include the NC Division of Coastal Management on-site pre-application meeting. For projects within a CAMA county that require a CAMA major permit, the NCDOT Natural Environment Section Permit Specialist will request an on-site pre-application meeting with the appropriate NC Division of Coastal Management field representative. The purpose of this meeting is to review the plans and/or permit drawings and information that will be submitted with the CAMA permit application. This will ensure that when the CAMA major permit application is formally submitted, it contains all of the information necessary for processing. The purpose of this meeting is not to make changes to the project design, construction methodology, or construction timeframe. However, if any potential changes to the project are identified at the on-site pre-application meeting, then they will be discussed with the full project team at the Concurrence Point 4C meeting prior to approval. At the time the hydraulic design is 100% complete and the permit drawings for the project are finalized, the hydraulics unit will hold a Concurrence Point 4C meeting. At the Concurrence Point 4C meeting, the hydraulics project engineer will present copies of the stormwater management plan to the project team members. A stormwater management plan is a project-specific stormwater design report. It outlines project involvement, river basins, classifications of the involved water bodies, selected structural and non-structural best management practices, best management practice devices, and major structures, bridges, and box culverts. The final permit drawings for the permit application will also be reviewed and revised based on comments received at this meeting. Any area where utility relocations affect additional environmental resources beyond the footprint of the roadway will be shown on the permit drawings and will be included in the impacts presented in the application. In addition, if the project is within a CAMA county and a CAMA major permit is required, then all utility relocations that are not included in the permit drawings will be described within the CAMA major permit application, either in narrative form or in a separate spreadsheet. The level of detail of utility relocation information required within the CAMA major permit application will be determined on a project-by-project basis at the NC Division of Coastal Management on-site pre-application meeting. The hydraulics engineer will record minutes of the meeting and will address the team's comments. Changes will be made based on the team's comments. The changes will be made in the permit drawings before the permit application is sent. Any changes to impacts to wetlands, streams, buffers, or AECs that occur after the 4C meeting will require the resource agencies to revisit the design and may require a new 4C meeting. The NCDOT hydraulics engineer will contact the agencies via email, letter, phone call, or scheduling a meeting as appropriate to facilitate review of these changes. The next two slides will show the information required at the Concurrence 4C meeting which the hydraulics engineer will present to the team. Project-specific stormwater management plan. Permit-related issues including impacts to wetlands, impacts to the jurisdictional surface waters, impacts to the riparian buffer zones, impacts to the wetland by roadway ditches, natural stream designs, riparian buffer rule compliance, and final recommendations of construction methods for bridges and culverts. This is an example of a permit drawing showing impacts to wetlands and streams. The impacts can be temporary and permanent. For instance, impacts from the roadway fill will be permanent. The impact of clearing outside of the sill slope in order to construct the fill slough will be temporary. You also need to distinguish how the impacts will occur. This is an example indicating hand clearing. The clearing is used for construction purposes, but we want the contractor to provide a level of care by not using heavy equipment to clear the area, but with hand clearing methods. An important environmental legislation in North Carolina is the riparian buffer rules. These rules are used to maintain adequate vegetation along streams to protect the streams and to provide treatment of stormwater flowing toward the stream. The buffers are distinguished into two zones. This is an example of a bridge project that crosses a stream that falls within the buffer rules. Often streams must be relocated for construction. When this occurs, the team will determine if natural stream design will be used to design a stream with stable characteristics. This can include a step pool, as shown here, which acts as an energy dissipator for the stream. This drawing indicates a stream with other natural stream elements. These elements can include veins, pools, etc. When natural stream design is used, the streams are categorized by a standard method using a morphological table. This table describes the geometry of the stream and the flow characteristics. An additional item that will be discussed at the merger meeting will be if any channels are proposed for temporary diversion. These diverted channels are used to move the stream temporarily away from the construction area so that the contractor can perform his work in the dry. A recap of several of the items that will be discussed at the merger meeting that relate to the permit drawings are shown, such as temporary impact due to diversion channels for culvert construction, construction easement, temporary impacts to wetlands and streams, impacts to wetlands and streams by utilities, and a final recommendation of hazardous spill retention basins. Another topic that needs discussion is if the contractor needs access for equipment or materials and needs a temporary haul road. These haul roads can be a significant temporary impact. Another example of a temporary haul road is the use of wood matting. Wood matting has been shown to be one of the best methods of providing access and allows the environment to quickly repair itself once it is removed. This is one of the largest work bridges constructed in North Carolina. The work bridge will be removed after construction is complete. This is the same work bridge as the previous slide, showing how the work bridge is used for equipment and for pumping concrete. Finally, one of the pieces of information provided at the merger meeting is the impact summary table. This is an example of a buffer impact summary. This table will list every impact along the project, identify the type, and in which zone the impact occurs. This is a similar table for quantifying wetland impacts. The impacts are categorized if they are permanent, will be made with mechanization, or will be impacted by hand clearing. In addition to wetlands, the stream impacts are quantified in this table. They are also categorized by permanent or temporary. The following slides include examples relating to Concurrence Points 4B and 4C. This is an area where a culvert is needed to carry flow from one side of the road to the other side. There are stream, buffer, and wetland impacts. Where are those impacts occurring, and what can be done to mitigate them? What can be done differently? This is the same example as the previous slide with modifications made to reduce the impacts. What are they? The lateral base ditches were modified by removing the portion of the ditch conveyed through the stream buffer and discharging into a level spreader located outside of the buffer limits. Two individual drainage system discharge points were combined into one system, which outlets into a preformed scour hole outside of the buffer limits. The preformed scour hole will dissipate energy and allow for metered dispersion. Additionally, the culvert outlet protection was modified by removing the riprap from the stream bed, resulting with riprap only lining the stream banks. This is an existing bridge crossing a stream and wetlands. This is the proposed bridge replacement. As you can see, the bridge length was substantially increased to provide a more natural flow pattern. The existing bridge only spanned the stream and did not provide adequate opening for the overbank flow. This is a cross-section of the same bridge, showing again how much longer the proposed bridge is from the existing bridge.